Okay, we're going to be looking at experimental probability with two-sided coins. So two-sided coins, just to give you a little bit of very vague background here. Essentially, that concept means there are just two sides to the coin. I'll put two circles here. The coins we're going to be using are pretty much circular, and we usually refer to one side being heads and one side being tails. So I'm going to take us to this website called random.org. It's a pretty handy website. Um, we have a coin flipper here. I'm going to flip 12 coins. So in other words, I'm going to flip, or you could say I'm going to flip one coin 12 times. And it gives you a whole bunch of coins to flip from. I decided to use the Canadian tuning. It's very neat. And when I hit flip coins, it's going to flip all of our coins. And then what we're going to do is we're going to build a quick bar chart, just taking note of what our experimental probability was. So here we go. We flip 12 coins. I'm going to scroll down just so you can see. We're going to quickly take a tally of what we got here. So this is a heads. This would be a tails. And this would be a heads, okay? So we're going to do a heads tally and a tails tally. So right now, we currently have two heads, one tail. Here is a tail. So that's 1, 2, and then another heads. Tail, tail, tail. That's three tails. So 1, 2, 3 tails, and then three heads at the end. Very interesting. 1, 2, 3. Wow, this worked out really, really nicely. So if we were to build a quick bar chart of this, let's say, let's go over and take a look. If we were to build a bar chart of this, it would look something like this. You have our heads and our tails. Okay. And if you remember the values, there was, I think we did 12 flips and it was right down the middle. So I'm going to say how many heads and how many tails. Well, we can go 2, 4, 6, 8, 10, and there were technically a total of 12 flips. Well, our heads got up to 6. I guess I could use straight lines for that. And our tails got up to 6 in the first time that we ran that experiment. That's really, really even, and we can, when we get into theoretical probability, we'll take a look at how lucky we were for that to happen. But I'm going to go back to this page, and we're going to try that experiment one more time. Here we go. Let's try that experiment again. Flip again. Here we go. So hopefully we have a whole new set. Apologize. So let's take a look again. So we have our heads and our tails. Actually, we did red last time. Let's change the color a little. There you go, orange. Okay. We got tails, tails. So that's 1, 2. We'll just count the tails. 3, 4, 5, 6, 7, 8. Okay. So 1, 2, 3, 4, 5, 6, 7, 8. And heads, we had 1, 2, 3, 4. So we had 1, 2, 3, 4. So that's an 8-to-4 ratio. Let's go and take a look at that. Okay, so here, I'll go back to orange. We had heads 4 times. Okay. And tails, we actually had 8 times here. So not as even. And that's what happens when you have experimental probability. It's not always going to be the same as what you would think it would be. That's the idea of an experiment. So in our first experiment, and to calculate experimental probability, let's go down and give a little formula here. So the probability of the, let's say the experiment, so this is your formula for this lesson, is the number of, we're going to call it positive outcomes, divided by the number trials. Well, what does that mean? Well, in both cases, our number of trials was 12. Remember, I decided to flip 12 coins. So for our red example, I'm going to call it PE just to shorten it up a little. And actually, I'm not going to call it E. I want to know the probability of heads. So the probability of H, okay, how many heads did we get in the first one? Well, we actually got 6. We got 6, and there's a total number of 12 trials. If you do 6 divided by 12, that means what's our percentage? Well, we had a 50% likelihood of getting heads. What about tails in the first experimental probability? Well, we got 6 tails out of 12. And when you divide that with a calculator, that is also 50%. Okay, what about in our second experiment? Well, the probability of heads is a little less. We got 4 heads out of 12. Is that going to be a third? So we have roughly 33.3 repeated percent of getting heads, not quite 50. And the probability of tails in the second experiment was 8 out of 12. 4, 3, I think that is 66.6% probability. I'm going to double check this just to make sure for our sake. 8 divided by 12. Yes, okay, good. Just wanted to make sure. Okay, so let's run one more experiment. Now that we've seen this and we can maybe try to make sense of it in our head here. Let's run our last experiment. I'm going to clear this page. There we go. Let's get back to the cursor. Okay, flip one more time. Okay, whole new set. Let's see what we get. Oh, what a great run. And let's choose another color. Yellow might be hard to see. Green, here we go. So what's heads? Well, we had 1, 2, 3, 4, 5. Okay, so 1, 2, 3, 4, 5 heads. And for tails, 1, 2, 5, 6, 7. Makes sense. 2, 3, 4, 5, 6, 7. 5 and 7 is 12. Good. There's 12 coins. That worked out perfect. So our final experimental probability, our final experiment, we had 5 heads. So that's roughly in the middle there for that bar chart. And we had 7 tails. So you can see they're similar, but not identical. So the probability of getting heads, well, we got 7 heads out of a total of 12 trials. I'll calculate that on the calculator in a minute. And the probability of tails, well, we got, oh, did I say that backwards? I think I did. Whoops, sorry, that's 5. We got 7 out of 12 for tails and 5 out of 12 for heads. So what does that mean to us? Well, 5 divided by 12. Ooh, that's not what I want to do. Let's clear it up, please. By the way, this is called Desmos Scientific Calculator. It's a great free scientific calculator you can use. Until it freezes like it just did. That's unfortunate. I have other options here. I have a little calculator I can bring up. There we go. I apologize. Oh, let's change this page off. Back to the cursor. Yay, 5 divided by 12 is 41.6 repeated. Okay. 41.6 repeated. I'm sure you're on your calculator, you got that answer far quicker than I did there. And then 7 divided by 12 is 58.3 repeated. So 58.3 repeated. Now, we got, in our experimental probability, 3 different probabilities every time. Right? And we're going to go into theoretical probability in a little bit, but take a look at that. Experimental probability can change every single time. It just depends on the experiment that you run. Okay?